Okay, let's do a more challenging problem. Let's do another example. Let's find all the node voltages at V1, V2, V3, and V4. Okay, so let's first identify all of our unknowns. This is V1, V2, V3, V4, and you know what? I'm going to throw one more in there because we have this 3Vx term right there. So that source is, it's another unknown. So we've got a Vx in there, and that Vx is the voltage across that 3 ohm resistor there connecting nodes 1 and node 4. Let's acknowledge the fact that we've got a couple of voltage sources. So we've got a reference voltage down here that's ground. We have a couple of voltage sources that are not connected to the reference node, namely the 20 volt source and the dependent 3Vx source. So those are supernodes. And so we are going to label them as such. I like to draw kind of a dashed line around them because it helps me remember that those are indeed supernodes. And so, so let's now do a nodal equation. First, we'll do nodal at, I'm going to write SN for short, for supernode, at the supernode 1, 2. Okay, so let's go ahead and do it. We've got a 10 amp source flowing into the supernode on the node 2 side. So we get a plus 10 amps. Then on the node 1 side, on the left side, we get the current flowing through the 2 ohm resistor. That's going to be a 0 minus V1 over 2. Then again on the node 1 side, we get the current flowing all the way through the 3 ohm path from node 4. So that's a V4 minus V1 over 3 ohms. And then on the node 2 side, we get the current flowing from the 6 ohm, through the 6 ohm path from V3. So that's going to be a plus V3 minus V2 over 6. And that's all equal to 0. And let's shop that equation a little bit. Let's machine this a little bit here, or massage this. Let's multiply everything through by 6 so we can clear some of that stuff out. So we're going to get, you know, we're going to get like a plus 60 amps. Or I'll just draw it like this, right? We're going to get a plus 60 amps minus, let's see, 6 over 2 is 3. So we're going to get a minus 3V1. 6 over 3 is 2. So we're going to get a plus 2V4 minus 2V1. 6 over 6 is 1. So we're going to get a plus V3 and a minus V2, and all of that is equal to 0. Now if we just collect terms and move things, move the constants over to the other side, we'll get a minus 5V1, right? Those are those terms right there, plus a minus V2, oh, whoops, hold on, minus 5V1 minus V2, plus a V3, and plus a 2V4 is all equal to, oh, whoops, is all equal to negative 60. And that's our equation 1, because we've moved that over to the other side. Let's get our equation 2 by doing by doing a nodal equation at the supernode, which again I'm abbreviating with SN, the supernode 3, 4. Okay, so into 3, 4, I'm going to erase some of these currents now because remember I'm just sort of drawing those in there as we're talking about them because they help us visualize which term we're writing in the node equation as we're writing it. So let's take a look at the current through the 6 ohm path. So now we're thinking of it as going towards the right, even though it's one or the other, it's right or left. But as we're writing this equation, we're considering all the currents going into the supernode. And so we draw them as all pointing into node 3 or node 4. So the current through that 6 ohm path is, well, we're going to write it as V2 minus V3, right? V2 is the far node, V3 is the near node of the supernode over 6, plus, let's talk about the current coming up through the 4 ohm path. That'd be ground or 0 minus V3 over the 4 ohm resistor. Now let's talk about, remember, you don't look at this current. That is, you can't know that. Even though this is a dependent voltage source indicated by the diamond, it, just like any voltage source, can produce any amount of current. And we don't know what that is. And that's why we do a supernode around it, because you can't guess what the current is. So instead, we're going to look at the current coming into node 4, the other side of that supernode. Through the 1 ohm path, that's 0 minus V4 divided by 1. And then finally, the current all the way from over at node 1 going through the 3 ohm path to node 4. So that's V1 minus V4 divided by 3 is all equal to 0. Let's go ahead and massage this equation a little bit too. All right, so I'm going to multiply that whole thing by 12 to clear out those denominators. Okay, so we get that this is then a, well, 12 over 6 is 2, right? So we get a 2V2 minus a 2V3 plus, well, 12 over 4. So we did that one. 12 over 4 is 3. So we get a negative 3V3, right? Minus 3V3. 12 over 1 is 12. So we get a minus 12V4. And 12 over 3 is 4. So we're going to get a plus 4V1 and a minus 4V4 is all equal to 0. And let's go ahead and collect terms and put them in increasing or ascending order, starting with V1. So we get a 4V1 plus a 2V2 minus, well, we had a 2V3 and a 5 and a 3V3 right there, right? So that's a minus 5V3. And then we had a minus, well, we had the minus 12V4 and the minus 4V4. So that's a minus 16V4 there all together. And all of that is equal to 0. And that's equation 2. Okay, so we have 2 equations. How many unknowns do we have? And we've done all the nodal equations for the 2 big supernodes, right? But how many unknowns do we have? 5. And so, wait a second, we need some other equations that are going to relate these variables. Now, just like in the last one, we're actually going to be able to relate, or the nodes 1 and 2 through the supernode value, and nodes 3 and 4 through their supernode value. So let's go ahead and do that, and we'll see how we relate Vx in there too. So I'm going to leave these equations here. We will bring equations 1 and 2 over to the next side when we do our matrix. And I'm going to set this up as we solve it by a 5 by 5 matrix. Okay, and we won't have to do any algebra. All right. All right. So there's the circuit. Let's get our third equation from the 20-volt source. Okay. The 20 volt source, well, what we have then is, if you're at V2, and imagine you take a little walk, you take a little mini walk to get over to V3, to V1. We can see that V1 is 20 volts bigger than V2, right? So V1 is whatever V2 is plus 20 volts. Or we could rewrite that as, if we move V2 over to the other side, V1 minus V2, the difference between them, is equal to 20 volts. And there's equation 3. If you wanted, you could go directly to writing that equation, right? You could look at this and say, oh, V1's on the positive terminal side, V2 is on the negative terminal side. So you could actually just go ahead and write, oh, V1 minus V2 is equal to 20 volts. And that's your equation 3 right there. Whichever way is helpful to you. So that's one of them. How about equation 4? Let's do the dependent, or the 3Vx source. Okay, so all right, V3 is on the positive side, right? V4 is on the negative side. So if you wanted, you could actually just say V3 minus V4 is equal to, what's the value of the source? The value of the source is 3Vx. All right, or you could say V3 is equal to 3Vx plus V4. That would be thinking of it as like you're starting at V4, you're walking along this way, and you gain an amount 3Vx, and that arrives you to the node V3. I really encourage you to think about yourself as a small little charged particle meandering around the circuit. And how does the voltage that you feel change as you move through those points? All right, either way you wanted to do it, what we want to do though is have everything in terms of the unknowns on the left side of the equation and all the constants on the right side of the equation. So I'm going to actually rewrite this as V3 minus V4 minus a 3Vx equals the constant 0. And that is equation 4. All right, we've got 4 equations with 5 unknowns. We need that 5th equation. All right, where does that come from? It comes from, we need to introduce another one that relates Vx in there. And that comes from the relation of V4 through V1. Whoops. Oh, dang it. You know what? Let me do this in another color so that it's a little clearer. Here's V4 through the relation of V1 as it relates to Vx. As it relates to Vx. So we can see that here's equation 5. V1, if you look at V4 is on the negative side of the 3 ohm resistor, of the negative side of Vx, the voltage across that 3 ohm resistor. If you add Vx to it, that, and again, imagining yourself taking a little walk along this circuit, then you encounter Vx, you add that Vx to it, that brings you all the way to V1. So V1 is equal to V4 plus Vx. Or we need to write all the unknowns or the variables on the left side of the equation, all the constants on the right. So this would be a V1 minus V4 minus Vx is all equal to 0. And that's equation 5. Okay, we've got 5 equations, 5 unknowns. Could we take some of these simple equations of V1 and V2 and V3 and V4 and Vx and stuff and plug them into these equations back here and solve it algebraically on paper by hand? We sure could. And we could sure spend a lot more time doing that than it would take us to assemble a matrix and let a computer solve this for us. Computers are really good at routine, mundane algebra, and let's leverage them for doing that. So, so let's go ahead and build that matrix. All right, so we're going to do a 5 by 5. Whoa, this is our biggest matrix yet. That's cool. All right, so our 5 by 5, and the unknowns in our matrix are the node voltages V1, V2, V3, V4, and finally Vx. All right, so let's go ahead and put equations 1 and 2 in. Equation 1 and 2. So here's equation 1. From the last page, we found that it was minus 5v1 minus v2 plus v3 plus 2v4 is negative 60. So that's a minus 5v1 minus 1v2 plus 1v3 plus a 2v4, nothing of vx is equal to negative 60. Be sure you do remember to write in those zeros where the other values come in, right? Okay, the second equation, equation 2, was this is a 4v1 plus 2v2 minus 5v3 minus 16v4, and nothing about vx is equal to 0. So what do we get? We get a 4, 2, a minus 5, and a minus 16. All right, let's go ahead and put that in there. 4, 2, minus 5, and a minus 6. Oops. Let's go minus 16. And that's a 0, and all of that is equal to 0. Okay, looking good. All right, let's do equation 3. Equation 3 is nice and simple. V1 minus V2, right? V1 minus V2 is equal to 20 volts. So we get a 1V1, a minus 1V2, nothing for V3, nothing for V4, nothing for Vx is equal to 20 volts. I'm writing this very well aligned here. That's a little better. Okay, let's do equation 4. Equation 4 is the dependent source. We had a V3 minus V4 minus 3Vx. So that's nothing of V1, nothing of V2. We have a V3, a 1 there, a minus V4, so a negative 1 there, and a minus 3Vx right there, and all of that is equal to 0. And finally, we'll put in equation 5, and we'll pop this one in purple just to, I don't know, color code it this way. We have a 1Vx, right there. We've got a minus V4, so that's nothing on V2, nothing on V3, a minus 1V4, and a minus Vx. Minus 1Vx is all equal to 0. So let's go ahead and just solve this real quick. I'm going to clear out the variables. Okay, so A is now, let's put our matrix in. This is minus 5, what is it? Negative 1, 1, 2, 0. Negative 1, 1, 2, 0. On the next line, it'll be 4, 2, minus 5, minus 16, 0. 4, 2, minus 5, minus 16, 0. The next row is 1, negative 1, and the rest zeros. 0, 0, 0. The next one is 0, 0, 1, minus 1, minus 3. So we got a 0, 0, minus 1, or no, hold on. 1, minus 1, minus 3. You have to be careful that you're not getting any typos in here. And then the last row is 1, 0, 0, negative 1, negative 1. So 1, 0, 0, negative 1, negative 1. Oh, whoops, just close off the matrix there. And so there's there's our matrix. Okay, so we'll clear that out, clear the screen. Let's then go and put a B vector in there. That's negative 60, 0, 20, 0, and 0. So negative 60, 0, 20, 0, and 0. And I'm going to transpose that with the apostrophe. And now we can do X. Our set of unknowns is A left divide B. And there's all the node voltages. Okay.